You can also make a table of ratio values to find equivalent ratios. This example here, we're looking at the cost of strawberries. 1 quart of strawberries we're given is $3, 2 quarts is $6, and then we're looking at 3 and 4 quarts. So it's going to be first best to determine the ratio, and then that will help us find how much 3 quarts of strawberries cost and how much will 4 quarts of strawberries cost. So we can kind of look at the patterns being established, if we can use our prior knowledge of ratios to help us find those missing values, and then maybe we can apply those same patterns and reasonings to other situations using a table. So we can see from the first column that we have 1 quart of strawberries is $3. So we can have the ratio of $3 to 1 quart. That then helps us with 3 quarts of strawberries would then be $9, since you're multiplying by 3, and 4 quarts of strawberries would cost $12. We can fill in those missing values once we have that first ratio to use to find the other equivalent ratios. Here's another example. If the ratio of boys to girls in a school is 2 to 3, we can use this ratio to find the number of girls there would be for any number of boys. In the table, you can see we knew 2 boys to 3 girls. Then we knew 20 boys to 30 girls, 200 boys to 300 girls, 220 boys to 330 girls. They all have that ratio of 2 to 3. So if there are 400 boys, how many girls would there be? Let's use that ratio of 2 to 3. We can use the 2 to 3 ratio and then set up a proportion with the 400 row for boys. And then we don't know the value of girls, so that would be X. And then we can use the fact that 2 to 400 is multiplying with a common factor of 200. So we can then multiply 3 by 200, and that gives us an answer of 600. So that's what would go in our table. So if there are 400 boys, there will be 600 girls based on that 2 to 3 ratio, and we can see that information in the table. So now here's an example where there's more values to fill in. Alexis wants some pink paint. In order to make the pink paint, she needs 3 parts red paint to 1 part white paint. So let's complete the chart showing the amounts she could use. The information that we're given to first find the ratio is the second column, where we have 3 to 1. So that gives us the ratio that there's 3 red parts to 1 white part. And we were told that information as well in the description above. So now we want to set that equal to, well, what if the first column, for example, is 1 red part to how many whites? So we can cross multiply and say that 1 times 1 would be 1. And then 3 times x would be 3x. And what times 3 would give us 1? Well, that would give us 1/3. So we can fill in that it would be 1/3 white for 1 red. We can continue to set up our proportions with that 3 to 1 always being the constant ratio or the beginning ratio. We can have 3 over 1 equals something over 3 for the third column. So 3 times 3 is 9. 1 times x is 1x, or just x, so that's already 9. We can have 3 over 1 is equal to something over 5. So 3 times 5 is 15, and 1 times x is x, so that would give us 15. We have 3 over 1 equals 30 over something. Now we don't know the white parts, so we'll still cross multiply. 30 times 1 is 30, equals 3 times x is 3x. So 3 times 10 is 30, so x equals 10. We have 3 over 1 equals something over 20. So if we cross multiply, that gives us 3 times 20 is 60, And 1 times x is x, so that's just 60. And then finally, the last missing piece, we have 150 over something. So that gives us 3 over 1 equals 150 over x. So 150 times 1 is 150 equals 3 times something. And that something here is then 50. So we can fill in 50 for the table. My work is a little messy over here. Let's clean it up. Let's get our conclusion. Again, just each time setting up those proportions, we set up 1, 2, 3, 4, 5, 6 proportions. We're always comparing that 3 to 1, but we then get the missing pieces of 1/3, 9, 15, 10, 60, and 50. So we can always use a table to find equivalent ratios. It's just a great organizational tool to help you solve problems.